Hello ladies and gentlemen, welcome to Online Distance Learning Algebra 2. Back here again with Mr. Hagedorn. Today's lesson 9.2 Angles and Angle Measures. Today dealing with degrees. First of all, the angle, it says in a coordinate plane an angle can be formed by fixing one ray called the initial side and rotating the other ray called the terminal side about the vertex. Now the ones that we're going to be dealing with are in the next statement. An angle is in standard position if its vertex is at the origin and its initial side lies on the positive x-axis. So that's what we're going to talk about when we talk about angles in a coordinate plane. It's going to be, unless noted otherwise, in standard position. Quick review of previous math. The quadrants in a coordinate plane go counterclockwise, starting at the positive x-axis and working your way about the origin. 1, 2, 3, and 4. So the first examples that we have here are just drawing angles in standard position, and then from there we can understand where they are and how to use them or find them. So the first one that we have here, 240 degrees, would fall somewhere between 180 and 270. So the terminal side would be found here in quadrant 3. The initial side, as always, is the positive x-axis, and then the angle arc tells us what direction we're going, determines whether it's positive or negative. An angle arc that goes in counterclockwise fashion, like this one does, shows that our angle is positive, and if it goes clockwise, it's negative. So the terminal side, and therefore the angle itself, is found in quadrant 3. The next one, 500 degrees, anytime an angle goes more than 360 degrees, the angle arc will tell us that. So if we start right here at the positive x-axis and we would go 500 degrees, we're going past the x-axis, but the question is how far? The answer is about 140 degrees, which would be somewhere right about there. Doesn't have to be perfect, it's approximately equal to that. So we'd still start here on the positive x-axis and we'd go around 360 degrees and come all the way back to that terminal side. That angle arc, which now looks more like an angle spiral, tells us that we went past 360 degrees once and then added on that 140 degrees to get to our terminal side or our terminal measure of 500 degrees, and therefore we find it in quadrant number 2. The last example that I have here are dealing with negative angle measures. So for this one, if we take our initial side still at the positive x-axis, but now as I mentioned before, we're going to go in a negative direction, or we're going to go clockwise about the origin. So for this one, the terminal side would be approximately equal to that, but our angle arc starts positive and goes clockwise to that terminal side. So in this case, our angle would be found in quadrant 4. So the next thing I'd like to take a look at here, ladies and gentlemen, are talking about reference angles. A reference angle is any acute angle, meaning less than 90 degrees, formed by the terminal side of the angle and the x-axis. So I'm going to go quadrant by quadrant here, and we'll talk about what the reference angles would be. So in the first quadrant, this is pretty unique. In the first quadrant, the angle that's given, theta, is its own reference angle. So any angle in quadrant 1 is its own reference angle. And that's because every angle in quadrant 1 is an acute angle. So the reference angle is itself. In quadrant 2, if that's theta, the closest terminal point we would have would be the negative x-axis. So in this case, it would really be what's left, or how much more do we have to get to that 180 degree mark. So in this case, in quadrant 2, the easiest way would be that the sum of the two angles would be the reference angle and the angle itself. Now once we get into quadrant 3, if this is our angle, which it is, it's theta, then we'd actually have to go back to the negative x-axis. That's the closest spot we have to the x-axis. So the angle would be whatever we've gone past 180 degrees to get to that terminal side. And again, ladies and gentlemen, that would be found in quadrant number 3. And last but certainly not least, quadrant number 4. There's our angle in quadrant 4, so that would be theta. Quadrant number 4, every angle in quadrant number 4, the closest place here would be to go back to the initial side. The initial side, the positive x-axis, would be the closest and therefore would create our reference angle. Or the easiest way to think of here would be that the two angles, the reference and the actual theta, would be the sum together would be 360 degrees. So if we take a look at the two examples we have down here, first thing we are going to do is we are going to sketch the angle, and then after we sketch it, we're going to take a look at it and find its reference angle in reference to the positive or negative x-axis. So here we go. If we have our angle, 127 degrees. Remember that when something is in quadrant number 2, its reference angle is what do we have left to get to the 180 degrees, or to get to that negative x-axis. So in this case, what plus 127 is 180? The answer is 53 degrees. So in this case, the reference angle for 127 degrees is 53 degrees. The second example I have here for you, negative 295, the only difference here is what direction are we traveling for our angle. So again, if we start at the positive and we work our way around, 295 degrees, negative 295 degrees would put us right about there. So the question we're asking ourselves is, since it's in quadrant 1, how far to get from the positive x-axis up to that terminal side? And in this case, the answer would be 65 degrees. If you think about it in terms of the absolute value of it, 360 degrees, whether positive or negative, to go full circle is what you need. So 295 plus what would give you that 65? And the answer is, or give you that 360, the answer is 65. So in this case, our reference angle would be 65 degrees. Okay? So the next thing I'd like to take a look at is just a more exact way of measuring in degrees, and that's using degrees, minutes, and seconds. I've given you kind of the background of how this works. 1 minute is equal to 1/60th of a degree. 1 second is equal to 1/60th of a minute, and also 1 second is equal to 1/3600th of a degree. Or there are 60 minutes in a degree, there are 60 seconds in a minute, and there are 3,600 seconds in a degree. So the way that we convert is we use those ratios. So if we go right down the line, there are 327 degrees to start. To that, we are going to add 16 minutes, which is the 16 with the apostrophe on it. That would be, if you look at our chart, the same thing as saying 16/60ths of a minute. And to that, we're going to add our seconds. We have 38 seconds, which again, if you refer back to our chart, is 38 3,600ths of a degree. So if we add all those together and we do our math as a decimal instead of a fraction, we would end up with the following: 327.2772 repeating degrees. Always give an exact answer, since we are looking to be as exact as we can with this type of a measurement. So that's how we would go from degrees, minutes, and seconds into a decimal degree. So the next thing I have for you is, how do we go the other way? Well, again, we look at it from the standpoint of the comparison of minutes and degrees, and then we look at seconds to minutes. So we know we have 127 degrees. That's given. So we know for sure we're going to have that. So the 0.59 is we have 0.59 or 59 hundredths of a degree. Remember, minutes are 1/60th of a degree. So if we use that, we could say that we have 59 hundredths of a degree equal to some amount of minutes. So in this case, if we cross multiply and divide, we get x is equal to 35.4 minutes. Well, again, we need to be exact. So right here, this is great. This is perfect. This goes up in our answer, 35 minutes. So now the last thing that we need to do is we need to deal with this 0.4. That 0.4 or 4/10 is how many seconds we have left. And if you remember from before, a second is 1/60th of a minute. So we can now put our 4/10 equal to some amount of seconds. How many 60ths are we dealing with? So once again here, if we cross multiply and divide, we would get x is equal to 24. So our final answer here would be 127 degrees, 35 minutes, 24 seconds. All right. The last thing I have for us today, ladies and gentlemen, are dealing with coterminal angles. Coterminal angles are the same terminal sides separated by 360 degrees. So for this one, ladies and gentlemen, it says state if the given angles are coterminal. Well, what we have to do first of all is we have to figure out what's the difference between them. How many degrees are found in between them? So if we take the difference of 840 and 120, we end up with 720 degrees. So the question is 720 degrees divisible by 360? Or in other words, is 720 degrees two full circles? The answer is yes. And since they are full circles, it means they come back to the same terminal side, and therefore they are coterminal. The next one says find a coterminal angle between 0 and 360 degrees. First thing I'd like to do here is apologize. This should be 476 degrees, not just 76 degrees. So in order for us to be able to find whether or not something is or is not coterminal, we have to be able to add or subtract 360 degrees. Since this one is above 360 degrees, to do it we would just simply subtract. Adding and subtracting by 360 degrees will give you coterminal angles above or below the original. So in this case, if we do that quick subtraction, we end up with 116 degrees. 116 degrees is the coterminal angle for the 476 degree angle we started with. And now the last one. The last one, kind of going off the second question we just had, is finding a positive and a negative coterminal angle. And the way that we do that is we add or subtract 360 degrees. So for this one, to find that positive coterminal angle, first thing I would do is I would add 360 degrees. Now if this doesn't do it right away, you may have to add again and again and again, how many ever times you would need to do it to get it to a positive number. In this case, if we add that, we end up with 145 degrees. So there is our positive coterminal angle. For the other one, I would just simply subtract 360 degrees from that. If you subtract 360 degrees from it, you end up with negative 575 degrees. Now, are those the only coterminal angles? Obviously not. They are just the first two that we've come across. So again, when you think coterminal, think a distance of 360 degrees. All right, ladies and gentlemen, that's all I've got for you for today. If you do have questions, please bring them to class next time we have it. Otherwise, stay healthy, stay safe, and Lord's blessings on your day. We'll talk to you soon.